Welcome. So, thank you for joining us for this workshop from Mathworks, and the title is How to Get Started with Machine Learning. And we're so happy to be here with the WIDS audience for this workshop. Now, before we get started, before we look into any logistics, before we start to do any task with machine learning, let's start with some introductions. So, I will start with my introduction, and then we will go to my colleague, Dr. Heather Gorr. So hello, my name is Louvere Walker-Hannon. I am a senior application engineer and team lead with Mathworks, and the types of problems I typically work on at Mathworks are related to a lot of AI and data science related problems that I try to help customers who use products from the Mathworks solve. In terms of my own background, so undergraduate wise, my background is in biomedical engineering. Graduate work wise, my degrees in geographic information technology, specialization remote sensing. What does all that mean? A lot of that means working with a lot of data, performing a lot of analysis, and yes, incorporating data science and AI. I also, every time that I can, I try to influence the next generation to explore data science and AI. So I do a lot of STEM outreach, especially related to underrepresented groups in technology. And today I'm here with a topic that I'm so passionate about. How do we get started with machine learning? And with that in mind, I'd like to hand over to Dr. Heather Gorr so she can introduce herself.
Thank you. Thanks so much, Louvere. I'm very honored to join you today. Also a topic that's near and dear to my heart, getting started with machine learning. I work for the Mathworks. I have my PhD is in physics, and during that process, I used machine learning to identify fluid characteristics. And so that kind of led me to the Mathworks, since I used MATLAB for that. That's how I was recruited. And since then, I've been helping users in that area doing this very thing, how to get started with machine learning, how to apply all these great things that everyone's hearing about in machine learning and deep learning, how to actually apply this to your data sets and what kinds of things you need to think about in the real world whenever we're doing this. And so I'm a product manager for MATLAB and focus on this area, just to be clear. Also, important things to think about is career stuff, right? So we want to always have that open discussion too. Feel free to ask us any questions about our backgrounds.
This is great. And thank you so much, Heather. And one other item too, Heather and I think myself have a bit of a presence on social media. So feel free to connect with us after the presentation to ask us questions about what you saw today and, possibly related to other topics. And let's continue. So the plan for today is to really have the opportunity to have you explore, how you can implement machine learning. So as a part of today's agenda, we'll have a setup in terms of logistics. So what tools we're going to use and kind of why we're using these tools, as well as some motivation related to why would someone consider using machine learning in the first place. We'll get an overview of the machine learning workflow. And, Heather, just to highlight, one of the items about machine learning is I think it appears anywhere and everywhere, but I'm just curious to get your thoughts. What are your thoughts about kind of where machine learning appears? Curious.
Yeah, I agree that it's anywhere and everywhere now. We're seeing a lot, excuse me, a lot more people starting to implement, as you know, in more embedded systems, in actual, devices. My lights just changed. Some is a small example of some of those devices. Those bring along the challenges. It's not just as easy to feed into a model and get the results you want. You really need to know about the problem.
Perfect. And this is so helpful because one of my biggest themes related to this particular topic is what problems are we trying to solve? And there are a variety of problems where machine learning could be applied. But in this particular case, we happen to explore one particular topic. And one of the reasons why this topic came up for me is because, I was thinking about this in conjunction with so much that we've been reading about and hearing about over the past few years related to climate change. And I was looking at a data set recently, and I saw the data set and I wondered, could we use this data to try to predict tsunami intensity? As we know, with so many things happening around the world related to climate related changes, it may be helpful to create some sort of machine learning model to see what can we predict in terms of the intensity of large-scale weather events. And that's what we're seeing here, or at least soon, related to the tsunami data. And then at the very end, you'll try to explore some resources that you can explore, but also leave some time for a Q&A with you as the audience. And let's look at some logistics. I know this is maybe the part that may not be exciting, but you know what? It's necessary. What tools are we going to use? So one tool is, in fact, communication. So as we're here with you during this workshop, please feel free to ask us questions through the chat. So both Heather and I will be available during the workshop to help out via the chat. There's another item. So we have some pre-work. So in terms of the pre-work, some of us may have received this beforehand. Some of us may be receiving the pre-work right here. What we're going to do is during the workshop, we will share this link in the chat with you. And this is going to give you access to a PDF document. I'll try to show this in a few minutes that points out the steps that you need to follow to perform this exploration as a part of the workshop. And we're going to be using not just MATLAB, but MATLAB Online to help us out with this exploration. And in terms of getting access to MATLAB Online, we'll share this link in the chat, but we're also going to share code with you. And we're doing this through MATLAB Drive. Think of MATLAB Drive as another tool still online, but this time this is where you're going to get access to files to help you with this exploration. So there's another link we're going to share in the chat to help you get access to these files in MATLAB Drive so you can use them in MATLAB Online.
Let us know, of course, if you're having any difficulties. We're here to help.
Great. And you know what? You just inspired me, Heather, where I'm going to exit out of the presentation and hopefully you can see on my screen where I have a Google Chrome browser. So that's one item. So please use a Google Chrome browser in order to do this exploration of MATLAB Online. This is a browser that we highly recommend using for working with MATLAB Online. In terms of MATLAB Online, this is a URL to the MATLAB Online license you have access to for this workshop and for roughly a week after we do this workshop together. Notice this is my starting point where it looks like I can visit the screen and press Access MATLAB Online, press that button. So what should I be able to do? I need to have a Mathworks account to get access to MATLAB Online. As a part of the pre-work, it does ask you to create a Mathworks account, which I've done beforehand. Just pressing the next button. And I think the largest challenge of all in this particular case is, do I remember my password? Which I believe I do. So let's sign in. And once you sign in, we should be able to get access to MATLAB Online. We need to also be logged in to get access to MATLAB Drive. So with access to MATLAB Drive, this is the folder that should be shared with you. So you'll see this in the pre-work, this model, tsunami, intensity, exploration folder. And within this folder, you should see these files. So there's a text file with some information, a MATLAB code file for importing some of the data. There's an Excel spreadsheet with tsunami related information. And then you have this additional file. It's a live script that points out all these steps to help us out with implementing the data science workflow and incorporating machine learning. Now, you're probably thinking, well, how does this connect to MATLAB Online? So I'm going to MATLAB Online, just where you saw, where it was located before. And in my current folder window, my content looks very different versus yours because I have a lot of other folders. You may notice on my screen, let me show this a little bit larger. So you have this model intensity, model tsunami underscore intensity underscore exploration folder. That blue and white symbol means I'm sharing this folder with you. And all I'm going to do is just double left click on that yellow folder icon. And guess what? I should be able to see those files. So that means I'm set up to run any sort of example code related to this workshop. So let me just, minimize that window. And that's essentially the setup. And as Heather pointed out, we will be available in the chat to help you out as you're performing this setup. One other note, the code is already written for you. The whole purpose, the entire goal is to make certain you can use an app to explore implementing the machine learning part that's related to the overall data science workflow. And I'll put the presentation back in presentation mode. As I'm working with my colleague Heather, as we're kind of sharing ideas, I'm curious about your thoughts about, machine learning as a part of the data science workflow. Is that something that you think is accurate, that you would agree with, or, would you, maybe think about it in another way?
Yeah, definitely. I think some people tend to even just focus too much on that aspect where it's, focused on the model, focused on tuning parameters, but, you're forgetting about all of the things that are going into it sometimes where, that how you're getting the data, how much of it, how it's labeled, all of those things really matter whenever you're doing those next steps, which, training the models like we'll get practice with soon. So I think that's one thing to think about, not only is it part of it, but it's really, the rest of it is also really important as we're going along, that, data discovery and exploration and prep really, tends to it gets sort of a bad rep sometimes because it's tedious at times, but it's really important and you can learn a lot too.
Perfect. Excellent. And then let's try to, focus and narrow down on the different types of machine learning we could generally find ourselves using. Now, I will say this, full disclosure, we're not going to use all of these types during this workshop. We're actually going to wind up using regression, but we'll point out why we're using regression in a few minutes. But just at a very high level, what types of learnings, do we generally have when we think about machine learning? So we have these two. So we have unsupervised learning versus supervised learning. So with unsupervised learning, I tend to think of our data being unlabeled, kind of out in the wild, so to speak, where we know nothing about this data and are trying to explore, are there any sort of groupings related to this data? And Heather, I wanted to ask, in terms of your work with unsupervised learning, do you find that clustering is used very often to help us figure out what's happening? Or
yeah, clustering is very popular because of, especially I think it goes hand in hand, like we'll talk about this in a moment, but first you're really discovering, are there natural groupings here or natural clusters that can be found in the data, and then after that, you can start to apply or be more confident and begin to apply classification, since there's some mathematical statistical relationships that will emerge once trained. So I think that's something that really helps. A lot of people will go use those hand in hand.
Perfect. Excellent. And then, shifting to supervised learning, where supervised learning, once again, I think about my data and I have some sort of prior awareness of this data. In fact, in many cases, people would probably hear that, oh, the data is labeled. And in terms of that data being labeled, that connects with this theme of, oh, you have some awareness of this data, what you're working with. So if I'm trying to take a set of data and classify this content into different categories, well, guess what? I'm probably exploring classification. On the other hand, with our example for today's workshop, I'm trying to figure out, what is the possible next. I'm trying to predict this next value for tsunami intensity. So that type of problem is well suited for working with regression. There are a number of different regression techniques. Now, I've got to admit, based on what I recall from school and also a large part of my work, a starting point based on the data that I'm using seemed to be linear regression. But keep in mind, based on your data, and if you're trying to solve a regression problem, you may not start with linear regression.
I almost always start with linear regression if it makes any sense whatsoever. Partly because, especially in MATLAB, you get a lot of nice methods along with that, which will help you explore the data. So even though I'm pretty convinced it's not linear, I can at least check it out. It's a really fast model to train, and it's very intuitive. You can plot, you can try to understand more about the data before you move on to one that isn't as easy maybe to relate back. So I think even if you're convinced you're going to use an SVM or some other kind of model, a lot of people will start with linear just for that, again, almost as part of the exploration process. And simplest is always best if you're trying to deploy. So, if that works, then a lot of people are pretty satisfied with that.
Perfect. Excellent. And with that in mind, let's actually get into the code and what we're going to explore. So with this idea, here we have an overview, and we'll highlight some of the code coming up next, as well as some of the steps we would like you to implement. So once again, we're going to study the predictors of tsunami intensity. So explore the data and build initial models. We don't need to be a regression expert. I think this is powerful because I think for quite some time, a number of people would think, oh, I have to be a regression expert to use this technique, when in fact, you don't need to. Another theme too, we're going to see a lot of these steps as a part of running the code. So loading data into MATLAB, using some interactive tools, and a particular tool for data visualization, using the Regression Learner app to run multiple regression models. So we'd like you to return to MATLAB Online. I will do that in a minute, and we'd like you to open up the file. Once you have the file open, it's important to have your cursor at the top of the file because you want to run this code sequentially, so going section to section. And note, executing the last section of code, it is optional. You'll probably see me execute this last section of code. So guess what? We are going to get into MATLAB Online. So with this in mind, I'm going to exit out of the presentation again. Hopefully you can see my Google Chrome browser again, and the tab we're going to focus in on where it says, MATLAB Online, R2021B as in Bravo, and I have this particular file open, so I'd already opened up the file. And I'm going to try to, make certain we can focus on, seeing the content in the file. So if you look closely, if I scroll thoroughly, you'll see, yes, I can see the output from the different sections of code. So one of the items you may notice when you're running the code section by section is you should pretty much see this output repeated. If you run into any issues, you may see kind of a red circle on the left-hand side, meaning something happened. Now, what does that entail? What does that mean? It could mean that we didn't run a particular section of code. Maybe something happened when we executed the code. So that's where you can reach out to us in the chat. But once again, one starting point, make certain your cursor is at this topmost line. In terms of running the code, I'm recommending section by section. The reason why I'm not suggesting pressing the run button is because it's going to run everything from the first line to the final line, and that final section of code really needs some output from that Regression Learner app in order to run that last section of code. So let's see about not using the green run button in this case. Instead, I'm going to use Run in Advance. If you notice closely, if you look at the data tip box, it has some shortcut keys where it says Control-Shift-Enter. So I'm actually going to use the shortcut keys. So I'm just going to try to run through this code quickly and point out those key items that you saw in the overview of the code. So using Control-Shift-Enter, I'm trying to run that first section of code. The major theme is getting access to the data. So in that variable data1, I have that content. Now, what does the content look like? So overall, if I visit the current folder window, I'm getting content from this Excel spreadsheet. And with this Excel spreadsheet, notice how I can open as text, I can get a preview. I'm just going to show you through this file that this is a large part of the table. If I click on this icon for view variable, you may notice there's so much more, 162 rows by 20 columns. Now, in terms of being able to see so much more, I can scroll to the right and I can see that I have, causes, the earthquake magnitude, location, maximum height, iota magnitude, the intensity. Notice for some of the columns, I'm seeing NaNs, which stand for not a number, which is some of the data we may consider removing and or filling in, as was highlighted. But just to point out, you do have all this data now in your MATLAB workspace. Let me close out the window. And then let's, explore visualizations. These visualizations that you're seeing are more specific to the geographic aspects of the data. So I'm just running that section where you can run that, but it would show in a map, where are these different locations where these events have occurred. But, let's shift back to the data science workflow part. And then there was some additional analysis just to show that you can analyze this data using a variety of techniques, and what you do for the analysis may depend on the data. So one person was interested in, let's only visualize data in one location and display that series of events using certain markers. I'm trying to not show this to you so you can click around and explore, so you don't have to be guided by just what I'm doing. And here's the part, here's the large part. We're going to do some further exploration. So this is a part of the code that has us getting access to the training data, the test data, and hopefully using the regression learner app. So we're just going to run this section of code. The theme here is this is your time to explore. So we're going to give you a few minutes during the workshop so you can explore, but I want you to see these steps. So one item is on the regression learner app should have opened up, and you have this regression learner tab. Let's import some data. So for new session, I'll select from workspace because these variables should be in our MATLAB workspace. So let's see. And for the data that I'd like to select, I'm selecting the training data. The training data is going to help us with training to get this model. Now, here's a big point, and this part I think relates to having a connection with your data, something that Heather mentioned earlier. I'm interested in finding out about the intensity of the tsunami data. So that means my response variable is going to be intensity. That's what I'm selecting. Now, here's the major theme. What do you do about predictors? And I have to say this, and Heather, I'm going to ask for your opinion on this. I'm going to do the following. I know a little bit about this data, and I read an article that pointed me towards, oh, it looks like these predictors are factors. So for my predictors, let me remove all. I'm going to try to be a little strategic in selecting these predictors. So from the article I read, it said earthquake magnitude, iota magnitude, and max height could be identified as, these predictors related to this, intensity response. And Heather, I wanted to check in terms of predictors, do you find yourself using all predictors when you're trying to explore a machine learning model, or do you take a step back and say, what may make sense? I'm just curious.
Yeah, I think exactly what you did is the perfect way to start, knowing full well that, just from your intuition, maybe you even have country or state, so you don't need latitude, longitude, you can kind of avoid some of that repeated information. And then other times you can just throw them all in and try to decide later.
Exactly. And then, other settings, I have to admit, I'm going to keep them as default settings. So for this cross-validation, I'm going to use these folds. I will keep them as they are. I'm just going to press start session. So for start session, that should import this data into the regression learner app, as well as I can see some visualizations related to this data. Now notice for this response plot, along the x-axis I have record number, and along the y-axis it says response, which is intensity. I would like to see along the x-axis one of those predictors. And I'm going to select iota magnitude. So based on what I read in the article, it told me that, there seems to be some sort of linear relationship. So that's what we're seeing now. Notice on the x-axis, it points out iota magnitude. But I need to do some other steps. So number one, say one of the largest. I can visit this area called model type, and I can select my downward arrow. And I have all of these options I can choose from related to trying to find out, okay, what machine learning models I could explore. But time is of the essence. So I'm going to select all quick to train. Should be. Let's see. Keeping my fingers crossed. That means I'm going to press the train button. And here's one item that I think about while we're waiting for this to train, Heather. So I always try to think about, well, what criteria is being used to select one of these options versus the other. And I think we see it already, where if I look at this area labeled models right here, I see where one option seemed to be selected versus the others, where it looks like, and just to kind of see the category, linear regression, but I notice for the validation that they're pointing out, it's saying root mean squared error. And it looks like the lowest root mean squared error is what 1 in this particular case. Now, just one note before, I check in with you, Heather, but, in addition to the root mean squared error, If you notice at the bottom where it says current model summary, there are some other calculations that are implemented to maybe help us determine, will I use this option or not, such as, R squared.
Yeah, I think the RMSE with, being closest to 0 is good. I think that's a quick, easy starting point. And then the R squared, like you mentioned, a lot of people find that pretty intuitive, and that should be as close to 1. And then also using those visualizations like you have shown, you can kind of see like sort of clusters. Maybe there's some, that's one of the more intuitive ways to check how the model performed, just making sure that there weren't sort of values that are being predicted incorrectly versus other ones. So that's another technique, just to use the visualizations there.
Perfect. And I'm going to your point about visualizations, I'm going to select that eye at a magnitude, because even though we see the two different colors, you see the blue that's supposed to be true and the yellow is supposed to be predicted. And we see that the blue and yellow have, seems like they're following the same pattern, the same trend. So I think with all of those factors, it looks like we can probably at least start to use linear regression. Now, there are other items we could use. So if we visit plots, there are quite a few other plots you could explore to see, okay, what else could I use to help out with validation? But we'll use these kind of default options for now. Now, one more item I'd like to point out is most of the time, if you're done training the model, you want to typically test the model. That's an option here too. I'm not going to do that, but you could. But I'm going to more so see about the following. We did all this work, which is great, but it's only in the app. Let's take this content outside of the app. So we could export the model. And in my case, I plan to export the model. There are other options, you can have the chance to explore, but for now, I'm going to select export model. And Heather, just to check in, when I go to export this model, do you, typically do anything else? Do you decide to use one versus the other, or is there anything else you think we should highlight?
Just to quickly highlight the difference, the compact model doesn't have the training data attached to it. Because of that reason, it's better for deploying, once you're satisfied. And then I generally just do export model, because that tends to have more of the methods and things you can use to explore it. You get more information if you double click on it. And so that's just for a little bit of context, that's usually what I try to do when I'm exploring.
Awesome. I'm going to follow your suggestion. I would do it too. So let's select export model. Now notice it's saying, okay, this is going to be that variable name. I'll select OK. Now, ideally, we'd like to kind of probably keep the Regression Learner app open. So if you go towards the upper right corner, you can see about minimizing. Okay. Now, technically at this stage, you're done running this code. But guess what? I really want to determine, based on that model that we just exported, by the way, let me minimize this for a second so you can kind of see that if you look in the command window after you export from the Regression Learner app, you'll see these messages that point out this is what was done. It's a confirmation message. So you now have a trained model in your workspace. So that's helpful for us. And it even points out some example code in terms of how to make predictions using the content from trained model. You can do that once again with some additional exploration. But for our case, for this particular example, I'm very much so interested in exploring, well, wait a minute, what if I got to the end of this code, which we should be up to? These are screenshots of the different steps that were just implemented. This is for your reference. But I'm curious, is there any way to determine which of those predictors seem to have the most impact on predicting tsunami intensity? And guess what? This, I think, is a perfect opportunity to mention another related topic. And this related topic is, okay, let's see about using some other techniques that are related to that data science workflow and specifically connected to machine learning. So I'd like to explore using a technique. It's called LIME, and it stands for Local Interpretable Model Agnostic Explanations. This can help us give some sort of insight into why the model is behaving a certain way. Now, is this the only option? No. And while I run this code, Heather, is there anything you'd like to add related to LIME or trying to get some level of insight related to this machine learning model?
Yeah, and I think this is such an important part of it, which people tend to skip over sometimes too much. Where you've got great predictions. Now what? You want to really make sure they're making the predictions that you expect. You're using the right information from the data. So Lime is a really popular one. There are several listed. We can share the link in the chat. There's an interpretability page from MathWorks that kind of pulls all these up. Of course, you've talked about it in some of your other sessions, but this is really important for explainability. Interpretability is so important to make sure you don't have biased predictions. This can help bring out some of those elements of the data set that might be biasing your end results. And so this step is very important. So I'm glad that you're taking the time. Again, the model type or the way that you're doing it, the approach could be many different mathematical techniques, but just the fact that we're pausing to talk about the importance of that step is important.
Awesome. And thank you so much, Heather. And thank you for shining light on the fact that this is not only important here with this example, but overall for all of us as a part of that machine learning community to think about how is this model getting these results? Because as you pointed out, there's interpretability, and I'm going to use the term, there's also the concept of AI bias that we should also think about with respect to this topic. And it looks like based on this output that we're seeing here, we have, it looks like, so along the x-axis, you have these coefficients. So the larger the coefficient value, there's a tendency this predictor has a higher connection. And the predictor names that we had selected before are on the y-axis. So it looks like iota magnitude. So this matches to what I read in the article, where it seemed to have this big connection to this particular model. And we saw it even earlier with the response plot, both before and after the training. This seems to be in alignment. On the other hand, earthquake magnitude, not as much, and max height, very minimal. So it looks like we have, and this is just the results in general that we're seeing. So it looks like maybe this is an opportunity to explore some more. So we'll give you some time to explore, but just to walk you through that step. So, thank you for seeing that overall example. And keep in mind, you will have access to this code to explore some more, not just during the workshop, but also after. And with this in mind, I'm going to go back to the presentation. But, as we're going back to the presentation, there's some questions I think we should ask ourselves. And then we're going to go through some final slides that point out some resources. So in terms of the presentation, I'll share my screen again. And Heather, based on those results, is there anything that came to mind when you saw that Lime output? Did it look interesting in terms of what we saw with the result?
Yeah, I think that sort of goes along with what you were saying, like sort of your instincts. I think that's also an important part of this. If you especially know your data sets, your work, you can use some of your instincts even, before and after, doing this. And then I think, like you mentioned, just being able to see that data, the line plot and like those kinds of visual representations will really help, be more confident that that's the one that is working, the best. So yeah, I think that's great.
Awesome. And thank you so much, Heather. And these are just some, items to consider after you do your exploration. So what model type did you use? Why did you select the model type? What did the response type plot look like with the selected machine learning model? I think that can help provide some window into what's happening, or maybe trying to check our assumptions. Were you able to export a machine learning model? I think that's a big piece from the app, in addition to the exploration. And then as a bonus, could you get a sense of what predictors seem to have an impact on the machine learning model? We saw that with using Lime, but as Heather pointed out, there's so many other techniques as well. And these are just questions for us to think about after we do that exploration. Now, my colleague Heather pointed out something awesome, and I want to highlight this slide. So Heather, I don't know if you'd like to, speak to this slide for, a few minutes.
Yeah, sure. I love it because I think many of us might think that, machine learning, deep learning, all these things are so new and cool. And this has been around for a very long time. So these are some screenshots from 1992 neural networks in MATLAB. So there's a lot of expertise out there. These things have been around very long time. You can, find all of the information that you need. Don't be afraid. We're all here to help you. I think that's one of the key things to take away from this. There's a lot of expertise will help, definitely.
Perfect. You know what? Looking at this slide and kind of thinking about the context of the topic, this makes me think of a line from a song, "Don't call it a comeback. I've been here for years." So it's one of those things where, yeah, this is not some new topic, and it's been around for a long time, and you can build on top of that foundation. There's a lot of newer options as well. And with this in mind, we're going to point out some resources. Once again, you will have access to a PDF copy of this presentation. You should be able to click on these links. I encourage you after the workshop, explore these on-ramps, which will give you some more hands-on time to explore some of the topics. So there is a separate machine learning on-ramp. There's also a separate deep learning on-ramp. But if you're brand new to MATLAB, there's also a MATLAB on-ramp. There's so many other resources as well, where we encourage you to explore these various links. And with that in mind, thank you so much for your time. Do you have any questions? And this is some additional contact information from Heather and myself. Feel free to reach out to us. And on our different forms of social media, we look for this She Loves MATLAB hashtag. So feel free to @ us, contact us. If you have any questions about this content, please let us know. And thank you so much for attending this workshop. And Heather, are there any final words?
No, thank you so much for having me. It's been a pleasure, and we've really enjoyed the session. Feel free to keep in touch, like Lou mentioned. We're active on social. We'd love to hear from you and see some of your examples and share some of your wisdom with everyone. Thank you very much.
Thank you. Enjoy the rest of the WIDS workshops.
Thanks.